All right, check one, check two. I think we are recording here. Hello, welcome. Great to see everybody whenever and wherever you're watching this video on Zoom, in the forums, what have you. My name is Alexander Booth. I'm the head program instructor and head facilitator for the IBM data science cohort. This is the April 2026 cohort, and this is our week 6 lecture video. So this does fall on a holiday in the United States, so not too surprised to not see too many folks online. But Karen, thanks for joining as our wonderful TA. Today we're going to be reviewing week 6. We'll go over some of the media sets and some of the notebooks. We're going to be going heavy into visualization and finishing up with interactive dashboard design. Should be a fun hour or so here. We got some good content in the forums. That's kind of what I'm scrolling through right now. As always, everything is backed up into my GitHub. And as we spoke about, we'll be covering Seaborn, Folium, Plotly, Matplotlib, Pandas, every plotting library under the sun inside of Python. And again, the point of this is to expand upon what we talked about last week with exploratory data analysis and move into the consumption layer is typically what I call it, right? We typically do visualizations for one of three purposes. The first being that exploratory data analysis, where we are improving our own understanding of the data. We're looking at distributions, we're looking at our violin charts, our box plots, right? Everything we did last week. The second use case for visualizations is for static reporting. So this could be things like visualizations in a slide deck, visualizations into a PDF that you print out and put on your boss's desk, embedded within Excel dashboards, things like that. And then finally, we're going to talk about the third use case, which would be business intelligence, basically creating interactive dashboards that create what we call self-serve analytics, right? Any user downstream can start exploring these data sets, asking their own questions, and gathering their own insights while having to go back and forth with an analyst or writing their own SQL queries. Sorry, I think my dog wanted to come into the study. All right, cool. So how do we basically move from data just in a table or database or any other extraction? How do we extract visual insights and then communicate that downstream in a consumption layer via interactive dashboards to power our data-driven decisions? Let's see, we'll talk about Dash when we get there. We're going to be using Dash as our interactive dashboarding tool this week. But when we talk about Dash, it's going to be giving you some JavaScript syntax, some HTML. But the big idea is business intelligence. So feel free to substitute Dash for Tableau, Power BI. Again, to me, it's less about the syntax of these specific technologies, but more about the big ideas of potentially what you'll see in the real world when you move into a data science career. Karen had some great context and specifically what Dash is. I was like, Karen, I'll let you explain this post if you want. It's just me and you, so feel free to,
Uh,
or we can riff off each other.
I suppose, yeah. So I guess what I was looking at is that because some of the paradigm that Dash uses is probably might not be familiar to people who have just begun with programming in Python. But I just wanted to give a brief, a kind of brief explanation of one thing is event-driven programming. So whenever we work with a modern graphical user interface, we're basically allowing the user to do things on the application, on the UI. They can do anything. They can click on this item, let's say, or this checkbox, or they can modify this input field. In this case, there's only one input field, or they can kind of, look at the page, they can highlight parts and copy and paste and so on. We want to be able to do something, as the user be able to do something on the UI, and you don't want it to be blocked. So in other words, you don't want to be in a state where it's sitting there and it seems like it's hung. So we use an event-driven architecture. So basically, what we have under the hood that we don't have to deal with, but it's kind of provided for us with, let's say, the browser, is you have a mechanism that maintains a queue of events. So anything you do on a UI element, like an input box, it when you do something to it, that raises an event and that's put into a queue. And then there's a loop that just goes through that queue and it takes the next event and it dispatches it to the appropriate function. And that's what the callback function is. So then we can have then the page be modified dynamically that way. So for example, it might say, okay, well, I need to get another set of items from the database or from this data set and modify, and update this graph. So that's what event-driven programming does. The other thing I talked about, and it's kind of pushing into a conceptual model because Dash doesn't really use this conceptual model a lot, but it's one that's called a model view controller pattern. So you have the model, that's your data stuff. So in this case, you actually, for example, if you look at the actual code, that's where it actually loads the data from the CSV. And it also has the function that filters out a particular year. So that's kind of the model part. So that's kind of the data layer. Then you have a view, which is actually just the UI. So in that case, you have a bunch of code like the example below here with HTML, where you're basically defining the UI, which is basically defining an HTML page. And so Dash provides a bunch of wrappers for HTML elements, and that way you define what the page is going to look like. And then the control section is when I do something on the page, that is how it modifies or updates the page, updates the application. So really, that was just what this post is about, and it gives a little more detail. So there you have it. I mean, basically an introduction to modern day graphical user interface development, but
Yeah.
in a nutshell.
Yeah, I thought this was really interesting. And yeah, just one thing to take off of this is like while this is goes like deep into the technology powering those GUIs, this event-based architecture does tie back into kind of what you see with a Tableau, Power BI, Looker of the world, right? Behind the scenes, all of those are going to be browser-based interfaces that behind the scenes just extrapolate a lot of this logic away. So as you are clicking on filters or dragging and dropping or clicking on bar charts and things like that, those are events that are happening that are triggering a change, right? So that's just the main big idea. In typical kind of
Yeah.
Python procedural code, we run the whole program top to bottom, the whole thing all at once. We don't listen for anything. But these other interactive technologies are much more declarative, where we're listening for events and doing a more request response, event driven, event triggering type of program.
Yeah, I mostly wanted to, when people filling in this area like a callback function, there should be some understanding of what you're filling in. Not just like
Agreed.
fill in this space, fill in that space, but like what is a callback function? I figured that would be really unfamiliar. And there I was, and here the product of well, I like to think it was a mini degree that I did at USU recently, and that was all in this stuff. So
Absolutely. All right, so let's get into some of the media sets and the code here. We'll spend a lot of time on Dash in the second half of the lecture. We're going to move from just introducing these static libraries such as Matplotlib and Pandas plotting, Seaborn, and then move into kind of the interactive layer with Plotly and Dash. So yeah, this should be some good stuff here. We'll touch on some of my favorite visualizations here because I think they're so not strange, but so esoteric. And they all have their use, but they're a lot of fun to do. So we have like a good activity on waffle clouds and waffle charts and word clouds that we'll tackle a little bit later as well. All right, let's get into things here. Let's fly through a few. Um, I think I spoke about this in my review or preview video that yeah, the first half of class is mostly around static visualizations and getting familiar with the different visualization types. And really what I think is the most important is going to be unit 2 and unit 3 here. So the advanced visualization topics, introducing kind of that dashboard design concept, maps, as well as those more esoteric charts, and then building those interactive dashboards. So let's get after it. We'll just click through most of these media sets here. As you'll see here, I don't think I'll spend too much time on a lot of the activities. But I like starting kind of a little bit straightforward with the Matplotlib example. So yeah, we'll talk about the overviews of visualizations. We'll talk about the overviews of different plotting libraries in Python. As we've talked about, there's a million of them under the sun. We'll talk about the different use cases. So hopefully you spend the time to go and watch these videos. Seaborn, just as a quick recap, the main plotting library in Python is something called Matplotlib. However, Matplotlib kind of struggles with statistical distributions and kind of advanced plots. Seaborn is a wrapper on top of Matplotlib to kind of better those statistical visualizations. So it's one of my favorite libraries in all of Python, so make sure you take the time to learn about it as well. Cool. So as we keep moving forward here, we're going to get into the basics of using Matplotlib to create static visualizations. And this should be the first activity that we will look at today. I did like this cheat sheet, data pre-processing. I will actually download this as well. And we'll attach it into our course materials. Pandas cheat sheet. Hopefully that gets saved. All right, and then as we start looking at our kind of next few things here, here we go. Cool, that just gets into that. All right, so let's move into our next activity, which should be our first coding activity. Well, we don't need to do pre-processing again, so we'll keep moving into our next activity here, which should take us into 6.3. All right, so this activity will be creating a basic data visualization with Python and being introduced and working with Matplotlib. So let's take a look at this guy. So we're going to use this as our soft introduction to the week here, to the lecture. We'll be using Matplotlib to create static visualizations. Notice everything that we do after this is building off of this foundation. We'll be creating statistical visualizations for our own exploratory analysis purposes, as well as trying to create more custom visualizations for static reporting tools. All right. Looks like we got our plot going. Let's minimize Karen's face, connect to our kernel, and get moving here. All right, let's clear output of all cells and get running. All right, so the first thing we're going to do is we're going to be working on a real data set. We're looking at real international migration data coming into and out of Canada between 1980 and 2013. As you saw in the last activity, we have already cleaned and pre-processed the data. So when we pull it down from the cloud, you'll see that it's already going to be hopefully formatted in a way that we can take straight into visualization. As we talked a lot about last week, I was like, is that new? They got my little A up here at the top. As we talked about last week, cleaning and pre-processing, getting good feature engineering for your data is really a precursor to building models or as well as building anything out in a consumption layer, anything downstream, right? Including dashboards, visualizations, reporting, etc. So here's what our data looks like. We'll see that we have the country where the migrants came from, their continent, region, and then the year, how many migrants from those country came into Canada. So the way to read this, 4,331 immigrants from Algeria moved to Canada in 2013. So let's still look at what our data looks like here. Again, we don't need to do much of that. And now we're ready to start visualizing our data. We basically have our x-axis with all of our years. Uh-oh, kernel died unexpectedly. Of course it did. 503, we crashed it. Hold on, let's see if we can refresh this. And, welp, service temporarily unavailable.
You jinxed it
No, we'll try this again.
and jinxed it.
Very cool. So yeah, let's just try that one more time. If this fails, we'll probably just review the notebook in GitHub or run it in Colab, but I don't really want to go into Colab today. Oh, maybe our colonel was still alive. Interesting. All right, so we should still have all of our data here. Cool. So let's get started visualizing our data set. So we're going to be using Matplotlib for this. Again, Matplotlib allows us to create static visualizations, so they're not going to be too dynamic. We're using a theme here, the ggplot theme. There's a lot of different themes out there in the world, so definitely go off and like look at all of these. Again, I like some of the Seaborn themes. I like the 538 theme, RIP. Dark backgrounds, always fun for dark mode. All right, so let's start talking about just making a plot, especially the integration between Pandas and Matplotlib. The developers of Matplotlib did great to, or I guess I think Matplotlib came first, Pandas came second. But Pandas incorporates the Matplotlib library natively within Pandas. So again, you'll see that there's actually a function called pandas.plot. Now, let me see if I can pull up the documentation for that. You'll see here that with Pandas Plot, it allows us to create a bunch of different types of visualizations native from the data frame, whether it's a histogram, whether it's a bar plot, horizontal bar plot, line chart, pie chart, etc. They can all be made from a data frame, and all we have to do is specify the columns for our X and Y, right? Only use if the data is a data frame. So let's see how this works. In this case, we're going to be creating a new data frame called Haiti, and this only contains the data from Haiti, and we're just going to plot it. By default, there's only two columns, so the function itself will infer what should be my X and my Y. I like adding a plit.show just to remove that little printed thing here. But you'll see here that pandas automatically populated the x-axis and the y-axis. So pretty smart. Already knew how to do this, and we can see a big spike happening after the earthquakes in 2011. We can also be more specific. So here what we're doing is we're creating our line chart, adding in a title and our X and Y labels, and then calling plit.show to show the full new image. So this looks actually pretty professional looking at this. We only have 4 lines of code. We were able to create a static visualization that I would feel pretty comfortable about putting into a slide deck or a reporting service. We can expand upon this one more time by adding an annotation. As we see here, we can see that the 2010 earthquake was the impetus for a lot of the immigration from Haiti in this period. And again, that corresponds with the story that we're telling. And again, that's really the power of data visualization is telling a story of how and why things happened, and then using that as a pattern to base decisions off of in the future. So very cool. We can do multiple countries all at once. This is called a multi-line chart. So what we're going to do here is we're going to plot both China and India on the same graph. And we'll actually see that this doesn't look right. While Panda's plot is usually pretty smart, in this case, it got the wrong idea of what should be an X and a Y. And instead we have an individual line for every single year, which is not what we want. So let's fix it. We're going to transpose the data frame and be more specific about what we want to plot. And there we go. We can see that migration from India and China parallel each other across the years, with again some spikes happening in the early 2000s. Very cool. We will kind of leave this last option as an exercise for the reader. Compare the trend of the top 5 countries that contributed the most to immigration in Canada. I guess we can look at what this is. Essentially, what we need to do here is grab the top 5 countries and save that off as a new data frame. And once we have that new data frame, we can then make our plot. So let's review the code here for that. So in our case, we're going to be uh, sorting our data frame by the total, grabbing the top 5, creating that as a new data frame, and then plotting that new data frame and adding in our labels. So if we scroll down, we should be able to see our beautiful chart here. So our top 5 is India, China, the UK, Philippines, and Pakistan. So let me know if any of this is surprising to you. I think it's interesting that maybe there's some different stories here, like UK immigration kind of dropped off going into the new millennium. which is interesting. And that corresponds to a rise in the Philippines, India, and China. Oh, I wonder also how much of these spikes correspond to also like other natural disasters happening in those countries. All right, so we'll save this off. Again, this is mostly just a warm up here. Again, our goal of what we were doing is just getting our hands dirty with basic plotting. So this is with Matplotlib and Pandas, and creating those static visualizations. All right, so we pop back to our media sets here. Notice that we're going to finish off Unit 1 by reviewing other common data visualizations that you'll see in the real world. So line charts are great at telling stories, especially of change over time, right? We saw our time field was the years, and the change we're looking at is change in immigration over the years. But what happens if we have more categorical data or if we have more numeric data? How do we start looking at those distributions, those correlations, or even just aggregations based off of different categories? This is where we can start using other plots, such as area plots, histograms, bar charts, etc. So definitely recommend watching these videos to understand the purpose of each. Area plots are essentially just like line charts. They're really good for change over time, but adding more ink onto the platform to help correspond and visualize those patterns as things go. Histograms allow us to look at the distribution of a single variable, so a lot like the violin and box plot charts that we looked at last week. This is mostly for numeric features. Bar charts is for categorical data. We're looking at different categories with a number. So, what is the total immigration by country? Country there is a category, total immigration is a number. We can create some pretty bar charts off of that. Let's see if I can find one on here. And and there you have it. There you go. Her voice, it's great. Just kidding. Anyway, we can see this is a horizontal bar chart here where we're using each year as a category in this case as well. So we're removing the time component from it. So again, different use cases for different visualization types. And then finally, we can end with the pie chart. This is a percent of whole. So again, it's also categorical, but only when we want to show percents typically. Almost anything you can create with the pie chart can also be created as a bar chart. And I think this is a good segue into understanding the purpose of why to know all these different visualization types, as well as visualization best practices with color, sizing, and marker style and labels. So at the end of the day here, with data visualization, it's really easy to lie with data visualization. So that would be something like maybe changing the visualization to maybe match your own biases or your own stories, or even just to conflate an argument, or even just to report falsehoods. So again, I'm not gonna, I'll stay out of the politics here, but I'll be using some politic visualizations because I think they're kind of fun. So we'll look at Fox News. Looks like I can get some data is ugly. There's a whole subreddit called Data is Ugly. So yeah, definitely feel free to creep on that subreddit. I think there's some really interesting, ugly visualizations there. But it's for a quick example because we just spoke about pie charts. This is a pie chart that was put on the news about a decade ago. And sure, maybe it looks that, oh, it's a really tight race, or maybe that's what it's trying to communicate. But you look a little bit closer, and none of it makes any sense. Like, again, since we're a percent of whole, all of the percentages should add up to 100. That is obviously not the case here. Palin in red should be the largest slice, but it'll look smaller than the green slice. What are we doing? So very easy to lie with pie charts. You'll also see this with the y-axis as well. Let's see if I can find kind of a good one. Yeah, so this is pretty maybe another interesting one. So if we look at this, it's supposed to be showing a dramatic increase in the amount of federal welfare from 2009 to 2011. However, if we look at the y-axis was my little pen. The y-axis goes from 94 million to 108 million. So that's an increase of only 14 million, which isn't that much that's like 10%, right? It's a 10% increase compared to like everything, the full budget here. But if we look at the graph, going from this smaller bar chart to this huge bar chart. They've distorted the y-axis to make this change look a lot more dramatic than it is, right? So this is a very common one, which is lying with your y-axis to
Or
maybe make something look more
or the
dramatic.
or the this one, if Bush tax cuts expire, that one looks really blatant. It's down the third row. Yeah.
Oh, yeah, exactly. Yeah, this one's an even worse example of that. Let me see if I can open
35
this.
and 39 is not that big, but when you zoom in on the axis that way,
Yeah. So again, what we're looking at here are bar charts. They go at 35 to 40 basically, which again is not really that big of a difference. But the way they visualize the graph, they've zoomed it in, so it's only showing a y-axis of 34 to 42, which expands and over exaggerates the difference between these two categories. So
yeah,
pretty
that's like
funny here.
the post I made with where I just made a, Joe versus Fred campaign, and they're only 1% off, but you zoom in, it looks like,
Yeah. And yeah,
the,
like
the
they do this all like this is a way more recent one with Tucker Carlson here. And again, you can see that they've done the exact same thing, that they've lied with the y-axis between 58 and 78 to make this dip a lot more dramatic than what it actually is. So anyway, definitely know about like data is ugly. So because of this, there are like best practices for making visualization. I like to call out Edward Tufte data visualizations principles. I like to talk about him more in the context of the data dashboards as well, but it's still some really good content here in his recommendations. Basically, we want to avoid misleading visualizations, right? So how do we have proportional representation of our data, right? We don't want to lie kind of with our y-axis. We want to make sure that we have clear labeling, clear data, clear want to have constant data variation as opposed to design variation. Let's see here. I also like the data to ink ratio when that gets brought up, which, yeah, I guess that's maybe fit into some of these other ones. But basically, how do we make sure that I'll share this article as well? And how do we just make sure that we are using standardized and truthful representations of our data, right?
if you
Um,
scroll down to the line one, not that one, but the lower one, lower down one.
this one.
One problem I have with those, okay, so you have a value for 1970, a value for 1973, and you have what looks like a trend between them, but there's no guarantee that that blue line is actually the value for, let's say, 1971. So that becomes problematic for me too when you use line graphs that way. Because it
Exactly.
implies you can interpolate between those tick marks, and if there's a gap, you're going to think, oh well, the latter part of 1975 must be this value then, on the line, but it's not necessarily at all.
So basically, it just means that big idea here with the great power of creating data visualization comes great responsibility to make sure that we're doing it and reporting it in a trustworthy way. Cool. Let me fly through a few more of these. I think the actual activities here, we can gloss over. I recommend doing them. I think it's useful to kind of walk through the other basic static visualization types, but it'll be pretty similar to what we did with Matplotlib. All right, just for the sake of time here, because I do still want to get through maybe two or three more notebooks and the quiz. And I definitely don't want to go the full hour and a half. But we'll see. Let's see how far we get. Advanced visualizations. This is mostly going to be extra bonus material, but to me, they're a lot of fun. I love kind of these types of visualizations. So creating more advanced plots. So we talked a lot about regression plots last week. So that's going to be your correlation analysis with your line of best fit. But I also think some really interesting graphs you can make around maps and geographic information, looking at patterns over geography. So this will be your like choropleth maps and heat maps and things like that. And we'll review this a little bit later on as well, going into the capstone. Some other good ones will be around natural language. which I guess will all be incorporated in this one and in the word clouds. So it'll be pretty cool. That's actually, I really love this notebook and activity. It's one of my favorite ones in the whole boot camp. So we're going to review it pretty fast here, but definitely take the time to do it. And again, if you make any of these more advanced visualizations for your capstone, I would love to see that in a few weeks. So this is popping up here, our waffle charts, word clouds, and regression plots. Let's go ahead and clear our outputs and get moving into it. So because we're doing some more advanced plotting here, we're going to need to import a few more advanced libraries. So we're going to be creating the new library word cloud, which allows us to visualize words, obviously, as well as PyWaffle, which allows us to create some basic waffle charts, which are a lot of fun as well. So we're still using that same data. So we're going to be looking at that same immigration data set from Canada. And again, this allows us to quickly compare and contrast the different stories we're telling with the line charts versus some of these more advanced ones. So a waffle chart's an interesting visualization that can usually be used to display progress towards a goal. I like to also think of it as another like proportion of whole chart as well. But we'll kind of show it's easier to explain after we see it. So we're gonna kind of hack one together and then we'll do the Pi Waffle library. So let me see if we can create kind of our first waffle chart. So you notice that we're going to be based off of matrices here. And yeah, this is again, this is kind of a hack, right? But it works. So let's look at kind of what this is showing. I'm trying to get the full. Oh, here we go. This is our full waffle chart. And there you go. What a good looking, delicious waffle chart. I know now we're all hungry. So yeah, like what this is showing here, right? We have three categories. We have Denmark, Norway, and Sweden, right? And kind of what we're showing is again percent of whole of all of the immigration to Canada from these three countries. We're looking at the percent of whole. So Sweden obviously incorporated over half, and as we see in our waffle chart, over half of our little squares are filled in. Right. So it's an interesting kind of chart. I think it's these are really easy to digest. Like I can just look at this really fast and be like, all right, Norway was the smallest, had the least amount of immigration of the three. And it's harder to lie with a graph like this versus a pie chart. And kind of as you'll see though, doing all of this steps is pretty inefficient. So I don't really know why they didn't start with pie waffle, but it's all good. We'll use their little helper function here. And again, it's something you can copy into other projects if you really wanted to. But here's how I would do it in the real world is by using the PyWaffle library. It's a pretty cool little library that sits on top of Matplotlib as well and incorporates really basically what we need to do. So as you'll see here, all we have to do is tell the function that I want to create a waffle chart, right? Here is the number of rows and columns, basically the number of cells that I want to fill in. Here's the column we're going to fill it in for. And then what is the data frame that we're going to be using? We're going to be pulling it from this data frame here. So let's see how it works. And boom, there it is. There's the exact same pie chart for Denmark, Norway, and Sweden. Again, same idea. We can see that Sweden is filled in a lot more. And all of these columns are completely customizable as well. Sure, why not? We'll show well, I guess, we'll let this be an exercise for the reader to do the China and India total immigration. All right, let's pivot away from waffle charts to word clouds. Word clouds basically allows us to see how many words, like what are the most popular words in any given text. This allows you to take like a whole bunch of product reviews or something, line them up and kind of see kind of what are the words that people are using when describing a certain product. So there's a lot more that I can talk about with natural language, but some of that will have to wait until we get into the um, advanced topics after kind of week 9 here. I suppose we get into generative AI and chatbots and things like that. All right, so what we're doing is that we are pulling from the whole like Alice in Wonderland book, and this is actually like a real Alice in Wonderland is open source, or what's it called? Public domain. So if we actually look at this text file, yeah, this is Project Gutenberg's backup of the uh, not open source, public domain version of Alice's Adventures in Wonderland. And so our goal here is to kind of see what are the most common words used in Alice in Wonderland. So we've already loaded up the word cloud, we've pumped in our book, and now let's see what are the most common words. So Alice said, there you go. Those are the most common words in Alice in Wonderland, which is pretty interesting, as well as little and queen. So all that kind of makes sense to me. Let's see if we can resize the cloud. And the next thing that we're going to do here is get rid of some of the stop words, right? So we're going to add said. We're going to say, hey, we don't want said to be a real word here. Otherwise, you would see words like the, a, am, me, you, all of those really basic words, which aren't very informative. So we're going to add said to the stop words and regenerate our word cloud. And didn't quite work. How did we? Oh, we needed to regenerate our word cloud, if I remember. Let me grab that. Boop, boop, boop. So let's add said to the stop words and then try and recreate the whole word cloud. Oh, still there. How did I do this earlier? I think maybe I just had to add it in. Let me check my backup because I definitely got this working in the backup. It's going to be whether or not I can find this notebook. There it is. Go, 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 GitHub. I believe in you. Boom, 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 boom. Aha, stop words equals stop words. That's what I needed. Boom, boom, boom. Plop that in here. Where are we? So we added said to the stop words, we recreate the word cloud, and then we regenerate everything. Boom, there we go. That looks a lot better. So now we see Alice, little one, no, as well as still queen and went and some of these other words here. So pretty cool. Last thing we're going to show here is my favorite part, which is basically adding a shape and forcing the words to take the shape of Alice in Alice in Wonderland. So we're going to try and force our words into this shape of Alice, which is, I think, so freaking cool. So let's run it, and if all goes well, oh my God, it actually worked. There we go. We can see all of our words, Alice, little queen, king, went thing. We even get the little bunny rabbit as well. Mad Hatter, whatever it's supposed to be. There too. So very cool. How impressive is that? We got a little word cloud in the shape of Alice in Wonderland. So very cool. Let's see how we can apply this to our immigration data. Basically, what we're going to do here is that, let's see, I don't even know what it's doing. Oh, it's creating some text for us. Basically, the we're making like a proxy based on the total number of immigrants is how many times like a word appears. So we can create a word cloud off of this in the exact same way. So again, what this is showing is that China and India had the most amount of immigrants into Canada, with smaller amounts from Morocco and Portugal. Very cool. Last thing I wanted to go over in this notebook, again on the advanced plots, is Seaborn. Again, I think Seaborn is a really powerful visualization library. So we're going to look at a few options here. Let's look at a count plot. Again, this is mostly going to be kind of like a bar chart where we're looking at the number of times so specific values appear. So we can see that Asia appeared almost 50 times, Africa appeared more than that. And again, this is mostly like unique countries. So not too much that I would kind of really go over. Count plot's not one of my favorites in Seaborn, but it is there and it looks pretty cool. We can do the same thing for bar charts. Let's look at how to build a bar chart in Seaborn. And again, I like that this as error bars because again, Seaborn's more of a statistical visualization. So this allows us to see like more confidence into what the true total for these countries or these categories would actually be. And then same thing, we can also make a regression plot. This is what we talked about last week when we do our line of best fit. So here we're just really quickly plotting that line of best fit as well as with a confidence interval because that's all the magic in Seaborn is confidence intervals and stuff like that. The statistics. So here's a green version. Very cool, very professional looking visualization with very little work. We have some more customization that we can do here, making it bigger, changing the marker sizes, right? Adding some labels, increasing the tick marks, all that good stuff. If you don't like the purple background, we can get rid of that as well. And again, don't get caught up in the syntax. What I want you to see here is the power of customization and visualization, as well as the different types of graphs you can make with these different libraries that we've talked about today, right? So let's see if we can create this little scatter plot as well. Let's just do that live. Boom, boom, boom. So what we're going to be doing here, we're going to be creating that regression plot with Seaborn for a couple of different countries. And if all goes well, we should have a multi-line regression. I guess we just have the one regression. So yeah, we're looking at just, oh yeah, we're just looking at the three countries here. There's definitely ways to get multiple regression lines as well on a single Seaborn page. So I definitely recommend looking at the documentation and looking at that. That's why I wanted to get like an example of the multi one here. Boom, 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 boom. Oh, they didn't show me one. But basically we can add like a different group and then we can basically fit multiple graphs on the same line, which is very fun. Cool. All right, good stuff here. Definitely want to keep moving. So let's save this and download the notebook. And let's keep grinding here. So let's get to the final project of the week. As we kind of talked through when we went through our media sets, you have another activity on Folium. I definitely recommend spending some time on this as using Folium is required for the capstone in week 9. I think week 10 is when you do it. But we'll go more in depth onto Folium in week 10 as part of the capstone project. All right, so let's pivot into the last section of the week, creating those interactive dashboards. So again, we have our media set with all of the different videos to watch. We introduce you to an interactive, to designing with dashboards. And again, a dashboard allows to have multiple visualizations that's interactive, kind of as Karen was talking about at the start of lecture, with those callback functions, event-driven architecture, et cetera, et cetera. Definitely recommend looking at articles around dashboard design principles. If I can type on my own laptop keyboard here. So, yeah, effective dashboard design, all these ideas of creating like best practices for BI tools, things like that. And then a lot of it is making it simplistic, making it explainable, right? Adding in context so non-technical users can actually interact with your dashboard. We're not just showing, we're powering self-serve analytics is the big idea here. So give clear actions. That's what I always like. How can someone use your dashboard? How can they start applying filters, things like that, right? So definitely I'll share one of these links as well, as we start talking about like best practices in dashboard design. I know that in our case here, because Tableau, Power BI, Looker, a lot of these BI tools are licensed, we're going to be using open source and we'll be using about yeah, that's actually really interesting. The cholera map that changed the world. I'll make sure to post this in as well. Or I think you have to make sure that this is like a real link. But yeah, very cool about how dashboards and different visualizations can really drive decision making. But like I said, we're going to be using Plotly, which is an open source interactive tool that can be used in websites as well as within Python. And Plotly allows us to create interactive visualizations. We'll skip over the Plotly basic notebook and kind of start diving straight into the dashboard design with Dash. So Dash is an open source interface built on top of Plotly. It allows us to create data applications as well as data-driven dashboard designs. And again, don't get caught up in the syntax of Dash. We will be using Dash as part of our capstone project in week 10 as well, so we'll get some more additional practice with it. But take a step back in this section and start thinking about larger business intelligence decisions as and dashboard design concepts, right? So that's what I would like you to take away here. A lot of content about how to code in Dash. It's a very popular library for technical users. Data apps are kind of exploding in popularity right now, especially with vibe coding and AI helping us out. As you'll see, with a more code-centric dashboard, right? Something created in a Dash versus a Tableau or Power BI. You have a lot more customization. When you use those licensed tools that are more built in with like Microsoft or Salesforce or Google Cloud, you have less customization as those products are parts of kind of a wider ecosystem. But with open source and specifically open source application software, you have more flexibility to design them in your own vision, right? So lots of good stuff with Dash. Um, I think we'll jump straight into the project. I did review the Dash basics um, in my preview video for the week. The only thing to call out is to make sure that you're always using Python 3, which is what the screenshots do, but the code instructions use Python 3.8, which is not the current version of Python we're using in the IBM platform. We'll be using Python 3.10. All right, so let's skip ahead to the practice project here. This is the keynote that I wanted to, I'm going to spend the most time going over here. So our goal, again, we have real data coming in from Australia on wildfires, and our goal is to use everything we learned this week, all the different libraries, Matplotlib, Seaborn, Pandas, Folium. So we will do some mapping as well to create and look at different interactive and static visualizations. And then on part two, we'll be showing a Dash application that you can build on top of this as well. So I'm not going to spend too much time reviewing syntax here. We'll be spending most of the time kind of reviewing the visualizations, their purposes, and how they're used. All right, good. So here's our first notebook in part one. So let's go ahead and clear all of our outputs and connect to our kernel. Cool. So notice in this activity, we're going to be using Seaborn for more distribution statistical-based visualizations, Folium for interactive maps, and let's go ahead and fetch our data. Again, I'm not going to go too deep into the data understanding here, but do know again that it is real data, and we're going to try and understand the story or the patterns inside of this data that we can tell. So, quick overview, just as always, from our data pre-processing. We do have some null values here. The confidence, we are missing about 2,000 rows, right? Our data types look pretty good. We do have a couple strings here. Date should probably be a date time. And then we got to make sure everything else is a real category. So regen looks like it's a category, and replace looks like it's a category. So it's just date, that's the wrong data type. Column names look good. I would probably lowercase everything, but other than that, they look pretty good. Last thing to note here is that we're missing maybe about, what's that? Almost 1% of rows for those. So it's up to us if we want to impute them or if we want to just drop them. I think we're going to end up just dropping them. So let's fix the date time, right? So we're going to fix our date time conversion. So basically all I'm doing is converting it to a date time and then extracting the year, month, and date. So a little bit of feature engineering. Pretty cool. That did work for all of my columns. We have our date time and we have a couple new columns here. So if we look at our data set, we should be able to have the year and the month as numeric features that we can then use in our visualizations. All right, so let's look at some graphs here. The first is we want to look at the change in average estimated fire area. Notice this is change over time. So I want us to use a line chart, right? That's kind of the big idea. So we're going to do a line chart here to show change over time. We can see there's a big spike in 2012, and then kind of we plateaued back out. Notice that we can do this a couple different ways. We can do this in pandas using pandas plot. We can also do this kind of just with straight with other kind of visualization. So notice here, I'm going by year and month in my change over time, not just by year. So we get a lot more jagged graphs. So we can still see the trend that it does seem to be in the drier months in the southern hemisphere is kind of when they have their spikes in wildfires. We can also do a bar chart, which may be a little bit more interesting to see. Notice I'm doing a bar chart here instead of a line chart. So same idea. Note that my axis looks completely messed up, but we're able to kind of tell very similar stories based on these two types of graphs. And so we're going to end up just by looking at a bar chart by year. And again, we can see 2011, 2012 were some bad years in Australia. So we notice the peak in the plot is between 2010 and 2013. Let's just look at those specific time zones. And again, we're looking at this by month between kind of that area. And these are all just static. These are more also like exploratory data visualizations. We've confirmed that a region is a category. So this is where bar charts are great. We're going to be grouping by region and then looking at the fire brightness column. So this is a great use for a bar chart. And again, with Seaborn, because we're doing a Seaborn bar chart, we have our error bars. Notice the error bars are tiny because we do have a lot of observations per region. So we have a lot of confidence here in our graphs. We can also show this with a distribution plot. So here's our violin plot, one of my favorite charts in all of Seaborn. We can see that in the WA region, our fire brightness peak is a little bit higher than the other regions. So that could be interesting. Same thing in the Northern Territories. We see that fire brightness is a little bit higher too. So pretty cool. We're starting to see the distributions of different data breakdowns within our groupings. Next, we're going to do a pie chart. We're going to be looking at percent of whole. We're looking at the percentage of vegetation fires per region. And again, we can see a majority here is going to be in the Northern Territory or in the WA region. Only thing to point out is that if I hadn't labeled these correctly, it would have been pretty difficult to tell the comparative size of these pie slices. So maybe doing a donut chart or a bar chart would also be just as impactful. It wants us to clean up our pie chart, so let's do it. So we're cleaning it up based on our labels. I would say this is even worse though, because now the labels are in over here, which are again pretty difficult to do as a comparison. So long story short, just be careful with pie charts. Let's look at a histogram. Histogram allows us to look at the distribution of a specific value of a specific column, very similar to our box plots and violin plots. So again, we can see this is fairly normalized, a little bit of right skew, but not a whole lot, and we're centered around 320 Kelvin. I'm using Seaborn here because I like the Seaborn plot versus Matplotlib a lot better. Look at how I just like the style of this. I think the bar breakdown is a lot sleeker, more sleek than Matplotlib's version. Let's keep blasting through a few more of these. Notice that with Seaborn, we can create more advanced visualizations. So again, we're grouping by region here. Again, this is a pretty ugly graph. I can't really see anything about it, but it's a fun graph at least. A lot of fun colors. Notice that we're gonna do our stack here to make this a lot more readable. So now we can see that the different areas are stacked on top of each other. To me, this is still pretty confusing. We see that, I guess you can see this kind of what the violin plot was telling us, that the WA, the peak in their brightness is a little bit more to the right than some of the other ones. It's peaking closer to 330, but like green is on Queensland is still close at 320. I don't know. I would probably still use a violin plot for this, but again, the idea here is to practice and interpreting and designing different types of static visualizations. We can do a couple regression plots, basically looking for any correlation in our exploratory data analysis. And there's really not a whole lot here. The scatter plot isn't very informative. If there's any regression, it's a very weak correlation. And finally, let's create an interactive map just so we can say we did one. Here is our goal here. Notice, yeah, there's always, oh, I am using the Cartop dark matter one. I was hoping that my background map would have loaded correctly. You may have some issues getting your background maps to load, but we'll talk about more about that in week 10. Idea here is that this is interactive. Folium is interactive. We can zoom in and we can annotate and draw different like dots and heat maps and stuff on our graphs. All right, good stuff. Let's pivot over to our Dash application and then review the quiz and call it a class. So much for finishing early. Sweet. So that downloaded. All right, so let's pivot over to our Dash application. Again, I'm also going to walk through I walked through how to set this up in the preview video, but we'll still kind of walk through it here. I'm just going to jump straight to the solution. So notice in our Dash project, we're in our Visual Studio Code fork, where we kind of have the instructions on the left and our user interface on the right. So again, we'll walk through kind of what it wants us to do here. We want to create an interactive dashboard using Plotly and Dash with interactive filters that when we interact with the filters, they change the underlying visualizations, our pie chart and our bar charts. So let's go ahead and set everything up. We already have our terminal already set up. And okay, there we go. So this is what I was talking about earlier. Notice how it's using like 3.8 everywhere. If I click into my terminal, which is just this little white area down here, or if you go to terminal, new terminal if you really wanted to. But if you type in Python dash version or Python 3, I guess, dash version, this comes back as Python 3.10, right? So because we're running Python 3.10 in here, we shouldn't be running 3.8 for everything. So you either have two choices. You can copy these instructions over and change them, or you can type them out yourself. And yeah, like I said, the screenshots are correct. If you look at the screenshot here, look, they got Python 3, right? Not Python 3.8. So the screenshots are correct, but the actual text itself isn't. So let's just copy these over and update them as we go. So we're gonna do pip install setup tools. Then we're gonna install whatever these are as well. And notice I'm getting rid of the .8. So this says Python 3 -m pip install packaging. And then we're gonna install our pandas and dash. And then this last one, it already uses regular pip3. So this instruction's correct. So we can just copy it over. I'll just wait for this to finish. Cool. So the last one here. And now we should be good to go. So the next thing on the instructions is to create a new file. So to create a new file, we're going to click on the two pieces of paper up here at the top. And then we're going to click on this first piece of paper that says new file. Our project is called -wildfire.py. This is still going to be that same application as the Australia data set we looked at on part one. So it gives us some skeleton code here. I'm actually going to jump ahead to one that I created earlier and then one that Karen created as well, and we'll compare and contrast the two of them. So again, make sure that again don't get caught up in the syntax, but definitely spend the time to go through this and notice about the inputs, the outputs, the callbacks, the event-driven architecture that we're designing here. So again, once I move over some of my code, yeah, let's say this is their full. I'm not sure if it's their full solution, but it's their full version. I think that may be it. Let me double check. I have one in my GitHub that I wanted to use, but I think that one is also
Yeah,
fine.
they show the full thing. The only I'm not
Okay,
very
perfect.
happy about how they format their code.
I also don't have your code in here, so
Oh, well, if you go to I can
I'll
bring
have
it
to
up.
get that later.
The only real difference, well, that's for the not that's for the not for the wildfire one. It's the whatchamacallit one.
I thought you did a different one for the wildfire. Anyway, here's the
Yeah.
wildfire app. One thing I'm going to change here is I'm going to add debug equals true into the app.run, and then I'm going to hit save on that. What that allows us to do is that if we change anything in the application, it'll live update, which is really fun. So let's run the app. As we said, to run the app here, the instruction is essentially just to go to Python 3 and then give it the name of the file. So our case, our file is called dash wildfire.py. That kicks off the app. It should say that it's serving on port 8050. So to actually open that, we have to go down to the last icon here, which is our IBM toolbox. Go to launch application, and our port is 8050. And then I recommend always opening these in a new tab. So we're going to click in the second button here to go to a new browser window. And if all goes well, we should have our interactive dashboard here. Yay! So we have our interactive pie chart. I can hover over it. I have my interactive bar chart. We can hover over it. We can zoom in, all that good stuff as well. How do I reset? Reset axes. And then as we start playing around with our regions, notice that both the pie chart and the bar chart all update accordingly, which is very cool. We can also pick any of the additional years and everything updates as well. So now this is your self-serve analytics, right? I'm able to be curious and start looking at different combinations of region and year and start identifying patterns based on the percent of whole for the calendar year, as well as some of the seasonality in our month by month bar chart down here at the bottom. Before kind of we look at some of the other, I think you're right. You did yours for for the capstone, right, Karen? I think you
Yeah,
created
I
a
think
different.
that no, I do have the wildfire one, my version, but it's not probably much different. The only thing is
No
I get a little
worries.
pickier about line break and indentations than they do to make it more readable.
I'll leave that as an exercise for you if you want to share any of that in the forums after class. We're getting a little tight on time, and I wanted to still review the quiz here. But yeah, one last thing I wanted to talk about in the code is just a quick review of some of the syntax, even though I said don't worry about the syntax. Just going top down here. We're reading in our data, we're doing our feature engineering, getting our new columns. Then we just work on building our page top down. So you'll see that our dashboard, we start with our title and then our filters. So we're going to start by adding in our title. Um, so you'll see that's what this H1 is. That's an HTML element. We're going to have this title here. We're then adding a new section. That's what this div is, writing a new section. So we're going to add in our region filter, and then we're going to add in our year filter. And notice we're hard coding in what those years should be and what those region labels should be. And then we get to the fun stuff, which is the interactivity, which is the callback functions, right? So essentially what this is looking at, we're looking at a change, an input. We're using the input or change to the region and year filters. And we're going to be outputting these two plots, right? The bar charts and the pie chart. So here's our little fancy function. So when the region or year change, we're going to be filtering our data frame off of the region or off of the year. And then we're going to be doing our aggregation and then creating our pie chart as well as creating our bar chart. And then we're just going to be returning those two figures onto the website. And that's it. That's all we're doing. So pretty fun, pretty easy. And again, with this debug equals true mode on, if I change something like in my title, like Booths, oh my God, Booths Australia Wildfire Dashboard, I just hit save. If I go back to the application, it automatically updated. How cool is that? So we have my updated title here. So this allows you to quickly iterate on your dashboard, trying new filters, trying new colors, trying new design principles, and seeing how it looks pretty easily. All right. How do I? Oh, let's go up here and I'm going to download this as well. Cool. All right, so let's kill the app and let's go over the quiz and call it a class. So to kill the app, I just hit Control C in the terminal and then I'm going to close the browser. All right, so hopefully this was kind of a fun overview here. Let me make sure I hit everything on my end. Again, learning objectives for the week, explain the purpose of the different data visualization types, review all the Python libraries, so your Folium, Seaborn, Matplotlibs of the world, Plotlies of the world, create interactive or basic, I call these like your static visualizations, create advanced visualizations, and then create dashboard design concepts to clearly communicate insights. Nothing in my slides per usual. And I do have my big idea lecture notes that I've uploaded to GitHub already. But yeah, you can review these on your own time. I don't think I had anything too crazy in here. Visualization's not just presentation, it's also a tool for thinking about data. Like I said, it can be useful as you explore the data set, right? That's kind of one of the first use cases is thinking about the data in a different light. Using the right chart for the right question. We talked about this already. Line plots used for change over time, bar charts for comparing categories, scatter plots for looking at correlations, histograms for understanding distributions, same with box charts, pie and waffle looking at percentage of a whole. And we talked about Tufte's principles already. How do we be clear and honest? How do we have clarity, simplicity, and accuracy in our data? We talked about and reviewed what is a bad or misleading graphic. And let's see here. We reviewed all these libraries as well as interactive dashboards. So pretty cool. I think my last big idea here, visualization is part of data storytelling. The ultimate goal is to tell that clear story. How should audiences be able to interact and answer specific questions to key insights and decision making, right? Let's see here. Visualization is it bridges the gap between analysis and communication and that consumption layer to your downstream stakeholders. Sweet. Cool. Let's go over the quiz and wrap up here in the next 5-10 minutes. So I'm going to go into the week 6 quiz. This is of course, the only thing that is graded per usual in the given week. And let's see how we go. I haven't done this quiz in a hot minute, Karen. So we'll see. 20 questions. Kill me
We'll just
now.
use the
Is it an easy quiz? I don't know who
it's
created
a little
Matplotlib.
harder.
Let's
It's
Google
a
it.
little harder.
Who, all right, well, hopefully we can get it done in
It was
10
John
minutes.
Hunter.
John Hunter, there we go. Created
And
Matplotlib.
part of the story, of course, is that his group they had a license for proprietary visualization software, but it was only on one could run on one machine, and they had actually a hardware dongle that they had to pass around the team. So it was really slowing down their work. So he set out to build a open source software
So
for visualization, which I thought was
interesting.
pretty neat. Yeah, I thought that's a pretty neat story.
With the inline backend, we're just creating the visual into the static visualization inside of the notebook. So as soon as it's rendered, you can no longer change it. You have to re-render the whole viz. Which code starts the command? Uh, percent sign matplotlib. It's a weird question. A and D are
That's the one
also
they wanted.
valid.
That's the one they wanted. I think it should be an inline because that's how the notebooks use it,
Notebooks do it. Yeah.
but
All
that's
right.
the one they wanted.
Cool. So we'll go with C here. What is a line plot display? It's a line fragments at different data points. Information as a series of data points connected by straight lines. I guess C here. It's a
Hmm.
weird question. Not a pie chart, not a
Yeah.
bar chart, and it's not line fragments. The lines are connected. Which the following is not a main layer of Matplotlib. Histogram. I would say histogram is a type of visualization here. It's not a layer of the library. God, this is a tough one. Tough quiz already. I'm sweating through five. Select the best description of a Jupyter notebook. This nothing to do with visualization, but I think it's B. It's
It's
not
B.
A because it's not for just for visualization. It's not C because it's not just a Python library. It's not D because it's not a data viz library. So that just leaves B. It's an application that allows us to create and share documents, including code, markdown, and visualization. Matplotlib was initially designed to serve a visualization. Yeah, that's a
Mm,
weird question too. Graphing, chart creation, data analyzer. I guess those are all right answers, but not the best choice. The best choice is matplotlib equals base visualization in Python. Select the option that best describes, again, best describes here, the three built-in interface classes at the back end. I think you have your figure, your canvas. I think it's A. I think you have no. I'm gonna say I think you have your figure. You don't have a figure and your figure canvas. Is there an event? Is it D? I don't even know what the answer to this question is.
it's B, if I remember right.
B, gross.
Yeah,
Uh,
really strange.
you have your figure canvas. You'd only have a figure canvas and a renderer, which is why I thought it was A. But
Maybe
I
it's
guess you can
I
also have
forget. We'll
event.
see.
Yeah, we'll see what happens. I would say it's either A or B here. What's the purpose of a line chart? Change over time. We've talked about that a lot. What? Capture
Yeah,
trends
but
and changes over time to see patterns and fluctuations.
it's A.
Display, is it A?
Hmm.
Capture data and
It
changes
almost looks
over
like the same
time.
thing for each one, doesn't it?
Yeah, that's a weird question. I would say it could also be C. I don't know. Weird question there for nine. I'm gonna go with A here. Capture, yeah, 'cause I think it's the more robust answer. We want to see patterns and fluctuations over time. Which of the following is not for comparing categories? Uh, Pie charts, bar charts can compare categories. Scatter plots are not. That's only numeric. And again, this is not ideal. Line plots, I would say no, but I could also hear the answer being yes. I don't know. What do you think, Karen? Do you think
Oh, I
line
know it's A,
plots?
B, and C. I know it's A, B, and C.
Oh, it's all three.
Yeah,
I would say you can compare categories of the pie chart.
I know. That's what I would think too.
All right,
So I
weird
guess it's a
question.
kind of, I guess it's the kind of thing where we can you can upgrade grade, the points on people if they get one of
Yeah.
one seems logical.
Yeah, so I guess if you do watch this recap video or this video,
Hmm.
if you are having issues with the quiz, just let us know and we can update the grades. But yeah, it looks like they're going with A, B, and C here. It's definitely A and B. I would say C is dicey, but whatever.
Hmm.
Which layer within Matplotlib generates the graphics and plot? The canvas, I think. No, the scripting
Uh,
layer, the backend layer.
it's
Oh,
the scripting layer, which doesn't make any sense really.
either. Yeah, this one
Because
doesn't make sense
the
either.
scripting layer is where you would define the plot, declare what it's going to be. I would normally say back the figure canvas or maybe the back end layer, but
Yep. The best way of statistically representing the data distribution, I think whenever I see data distribution, through five main dimensions, so we want them next to each other. So I think I want box plot here, because histogram is usually just one dimension. So in this case, we're having our group by five, and we're gonna have five box plots next to each other. So like the two Seaborn plots that are useful for data modeling, regression plots. I don't know, categorical plot.
Mhm.
I guess those are the only two that are specialized in Seaborn.
But
I would say
especially
you
for
can,
Seaborn, yeah.
yeah. Pie plots and bar charts obviously exist outside of Seaborn. Callback function is automatically called by blank when an input component's property changes. Python function that is automatically called by. I don't know. It could be
Think the
BC or
framework
D here.
dash. It's dash.
You just want D.
That's the
That's dumb.
framework that is being calling the
Yeah, I know,
Python
but I was
code.
like, you could have callback functions in regular Plotly, and HTML can also trigger a Python function.
Except you can't, except HTML, for example, you won't call Python code. HTML file, you only
Again,
call
if it's
JavaScript
Flask.
file. So, but
That's true.
that's
That's
that,
true.
and dash is in as a wrapper around Flask. It's built on
Fair enough.
Flask. So
All right.
you're calling the back end then for to get what the the to run the Python code, which
Gotcha. All right. So and we learned Dash this week, so it makes sense that this is Dash. Choropleth, this is true. We're gonna shade in areas on the map proportion to some variable. Which two parameters are needed to decorate a callback function? We reviewed this as well in the code. We need an input and an output. A Plotly graph contains a JSON object which has a dictionary structure. True?
Mhm.
True. Almost done here. Waffle charts represent categorical data. It's like a pie chart, percent of whole. That's my guess. What's the default map style in Folium? It's going to be the OpenStreetMap, the open source library. And that's what we kind of had some trouble rendering at the end there. But we'll do some more debugging of Folium in week 10 when we work on it in the capstone. All right, I'm going to finish this attempt and we'll see how we do. No promises, but hopefully we get above a 90 is my hope. Let's see how we did. Oh, look at that. Because we had Karen on the line to give us all the
I
answers.
was gonna say what
So
you would have flunked without me.
I would have got a B. I think I would have got a solid B. But yeah, let's see. So we got all the right answers here. So just to review, John Hunter created a matplotlib. After the figure is rendered, it can no longer be modified. We use the percent matplotlib as our first matplotlib function. Line plot displays a data connected by lines. Histogram is not a layer of Matplotlib, it's a visualization type. Jupyter Notebook is an open source web application. Matplotlib was developed to create visualizations. The three built-in classes are figure, canvas, and renderer and event. I believe it's figure, render, canvas, but whatever. This also works. Just the events in Matplotlib are just interesting. Purpose of a line plot, capture trends over time. This is the best answer. We only use bar plots to compare categories. Pie charts are debatable. The scripting layer creates the graph itself. Box plots allow us to look at data distributions across multiple dimensions. Regression plot and categorical plots are specialized plots in Seaborn. Callback functions are called by Dash and the Dash framework, as we talked about at the end of the lecture. Core plots show areas on a map. Callback functions need inputs and outputs. Plotly does contain JSON objects. Waffle charts represent categorical data, and the default map type is OpenStreetMap. Heck yeah. All right. I'm already a couple minutes over, but this was fun. Hopefully, you all had some good times in week 6. Quick look ahead into week 7. Week 7, we're going to be introducing our machine learning week. So we have 2 weeks of machine learning. So next week, we'll be doing a deep dive into supervised machine learning, regression and classification modeling, and linear modeling. So it should be fun. And then week 8, we'll do our more advanced machine learning topics with unsupervised machine learning, neural networks, model serving, model evaluation, all that good stuff. So should be a fun couple of weeks here coming up. Looking forward to it. All right, thanks everybody. And if you're in the United States, happy Memorial Day. Enjoy kind of the rest of the week. And I will see everybody in the forums going into Wednesday and Friday as we launch week 7. Anything on your end, Karen? Nope. Awesome. All right. Thanks, everybody. I'm just going to end the recording here. And Karen, I'm going to log off of the Zoom. Thanks, all. Have a great week. We'll talk soon. Take care.